All right, we're going to explore how to figure out if a function is linear or quadratic based off of the table of values. So just to kind of start this off, I gave you a table of values and a graph, coordinate plane. So if you graphed it, -4, 7, you'd go left 4, up 7, plot your point there, left 2, up 6, 0, 5, I put 3. Left 2, up 6, 0, 5, 2, 4, 4, 3. And as you notice, this is making a line, right? Just based off of those values. Now, for part B, if you were to plot these points, -2, -8, 0, 0, 2, 4, 4, 4, 6, 0, it's clear that these don't make a line, and you might be thinking, oh, maybe it's absolute value. We just talked about that. But if you were to draw a straight line between those, it doesn't touch these two, so it's not absolute value. When you connect them, it actually forms a parabola, which means this is a quadratic. Quadratic. So let's take a look at the table of values. I just wanted you to visualize it at first, but let's take a look at the table of values, and I could have written linear here. That helps prove that this is in fact a line or a quadratic. So what you could do is try to find the slope, or in other words, the first difference of the y's. So if you did that, you could subtract 6 minus 7, like y2 minus y1, and that'd give you -1. You can continue subtracting the y2 or the 5 minus 6 to give you -1, the y2 minus y1 giving you -1, and the 3 minus 4 to give you -1. Notice how these are all the same. That's a hint to you that it would be linear. If the first difference, and as we know in math, difference means subtraction, or in this case, we're subtracting the y's, and we could subtract the x's, and we would notice that that has a constant rate of change as well, which means that it would be linear. We focus on the y's more so. First difference, if they're all the same, it's linear. Now, on the other side, when we look at quadratic and we subtract, find the first difference, we could do 0 minus -8, that gives you 8. 4 minus 0, that gives you 4. 4 minus 4, the y2 minus y1 gives you 0. 0 minus 4 is -4. Now, these are clearly not the same, not a line, not linear. But if we do the second difference, if we subtract a second time, 4 minus 8, let's see what happens. -4. 0 minus 4 gives us -4. And -4 minus 0 gives you -4. These are all the same. When the second differences are all the same, that means it's a quadratic. Okay, so if you look for those patterns in the lines, the first difference, when you subtract, that gives you a line. Second difference, if those are all the same, it gives you a quadratic. So if we take a look at that example number 5, we can either do it together, or you can try it on your own and then just check at the end. You want to see from the table of values what the relationship is, either linear, quadratic, or neither. So if the first differences are the same, that means it's linear. If the second differences are the same, it's a quadratic. If neither of those are the same, that's when it's neither. So let's take a look at this example and see which one it is. Now, again, y2 minus y1, the 3 minus 12, so that's -9. 0 minus 3 is -3. 3 minus 0 is 3. 12 minus 3 is 9. Clearly not a line, because the first differences are all different, but we could subtract again. -3 minus -9, make sure you're subtracting those negatives to give you 6. 3 minus -3, giving you 6. 9 minus 3, giving you 6. Notice how these are all the same. That means it's a quadratic. Now you might be wondering why we're not subtracting the x's. Since we're just doing a basic overview, we're not going to try to trick you and give you a different rate of change for the x values. Notice how these just go up by 1, so we don't have to worry about it as much. But yeah, in the future you may have to look into that. But for now, all I want you to know is first differences are linear if they're all the same. Second differences, if they're all the same, it's a quadratic. There's a couple practice problems on your homework and on the review, so you can try those out if you want more practice. Good luck.